Hi everyone, welcome to Math Session 1. We're going to have 16 lessons just like this, and this is Session 1. We're going to start each lesson with a number talk. Here's today's number talk. Are you ready? The first thing we do is we take a look and we entertain possible solutions. That's where we're at right now. Possible solutions. So, where my black marker is. Here it is. Possible solutions. What do you think? Knuffle Bunny?
3.
Excellent. Alrighty. For this number talk, Gerald?
6.
Here we go. Skippy John, you have a thought?
21.
Maybe. And Piggy, what do you think?
4.
All right. So these are possible solutions. Remember, that's what we do first. We generate some thoughts on what might fit in our number sentence missing number. One of these might be true, and you can prove it by defending that number using these words. I can defend blank because, and you explain your thinking. What strategy, what process, or what tool did you use to figure it out? All right, so Gerald, you have a thought? What do you think?
I can defend 3 because I used the number grid tool and I went from 9 to 12 and it was 3 hops back.
So on your number grid, you started at 12.
Yeah.
You went 1, 2, 3 hops back, and you landed on 9. Nice thinking. Awesome. Piggy, do you have a possible?
Well, I can defend 3 too because I count up in my head. 9, 10, 11, 12.
So here's Piggy. And she's thinking, sometimes I do this, in her head. And she started at 9 and then went 10, 9, 10, 11, 12. Is that what your brain did?
Yeah.
Awesome. And you called that counting up?
Yeah.
Awesome. You start from 9 and you count up to 12. Count up to the big guy. Sweet. Knuffle Bunny, what do you think?
Well, I said
Whoa.
I can defend 3
Excellent.
because I used my fingers and I kept 9 in my head and I said 10, 11, and then 12.
Aha.
And I knew that.
So you
It
had
had to
9
have
in your head,
Yeah.
and then you used your fingers to track your counting, to count up, right?
Yeah.
So it's kind of like this counting up, but when you did your count up, you went 9, and then you put up a finger 10, 11, 12. Is that how you went?
Yeah.
10, 11, 12. Wow, great job. Hands, your fingers, they sure are handy, aren't they? It's a great tool to use. And finally, Skippy John, do you have a thought on one of these? What do you think?
I can defend 3 because I make a 10 and add 2 more.
Oh,
So I know
okay.
that 9 plus 1 is equal to 10, and then I add 2 because I know 9 and 1 makes a 10.
9 plus 1, 9 and 1. Excellent. You make a 10. And then you needed 2 more, so you added 10 plus 2 to get to 12. Is that right?
Yeah.
Wow. Fantastic. Great work today. Hi, we're about to move to our Math Boxes page.
We're rolling.
My friends, here's what we're doing. First of all, before we get to our boxes page that we're working on today, I need to help you know about function machines. They look like this. You might notice it'll be similar to your frames and arrows patterns. what the deal is, when you're solving what's my rule problems, you're going to find the rules in missing numbers. First of all, I need to look at the number patterns to figure out the rule. So for instance, if I see a 1 or 7 right here and a 5 here, if a 7 goes in, what's going to come out? There must have been some action that happened. So I look, 7 turns into 5, 11 becomes 9, 4 becomes 2. The rule must be take away 2. Did you notice how I went back to on each one? Once I figure out the rule, then I can solve the one that might be missing. So 9 take away 2 is going to be 7. Over here, again, the rule is missing. So I look at the number patterns to figure out what the rule might be. 1 becomes 5. 3 becomes 7. 4 becomes 8. Aha. I'm noticing the numbers are getting bigger. Over here, they went smaller, which means subtract. Over here, the numbers are getting bigger, so it must be adding. I know that 1 plus 4 is 5. And that rule fits for 3 plus 4 is 7. 4 plus 4 is 8. That was an easy double fact. And 2 plus 4 is 6. On this one, whoa, the numbers look huge. I'm getting a little bit nervous. But wait a second. Looking at the pattern, figuring out the rule, 33 becomes 43. I know when I'm on my number grid and I go down one box, 33 becomes 43, and down a box is plus 10. I should have checked here to make sure it fits. 12 becomes 22, 50 becomes 60. Well, that was the easiest one. 28 then becomes 38. And if you use your number grid while you're working these, it could be a really helpful tool. All right, let's try this one. 1 becomes 2. I see the numbers are getting bigger. 2 becomes 4. At first I thought it was like 1 plus 1, but then 2 plus 1, 3 becomes 6. Wait a second. Are you seeing double facts? 1 plus 1 is 2. 2 plus 2 is 4. 3 plus 3 is 6. Aha! The rule is double. That's fun. 4 plus 4 is 8. 6 plus 6, 12. Awesome. Here's another page of function machines. I want to just make sure that you guys get this idea. This one, the rule is already here. Whew. All I have to do is the work. 1 plus 5, out comes 6. 6 plus 5. 6 and 4 is 10, and 1 more makes 11. 3 plus 5 is 8. Turnaround fact. And 10 plus 5. Oh, I can just put a 5 where the 0 is, right? That's 15. Awesome. Okay, right here, I don't know the rule. So when it says find the rule, I have to think, what pattern am I noticing here? 8 became 5. 11 became 8. 5 became 2. 9 became 6. The numbers are getting smaller. I must be subtracting. What did 8 take away? 8. 7, 6, 5. Take away 3. 11, 8, 9, 10, 11. I can even do count up. Sure thing. That fits. Here's a few more, just to make sure you're getting the idea. This one, I need the rule. Woo! 5 becomes 9. 8 goes in, comes out 12. 10 and 14. Ooh, this one is the easiest one because I know the 4 can go right in there. So this must be plus 4. Over here, take away 10. Wow. Okay, so 16, take away 10. If I go up one box on my number grid, I land on 6. But whoa. I know what comes out, but I don't know what went in. I have to do the opposite function. Wait, what? Oh yeah, so instead of 12 take away 10, I have to do 12 plus 10 to figure out what goes here, what went in, and then I took away 10. So 12 plus 10 is 22. Sure enough, 22 take away 10 is 12. 23 goes in, take away 10, I'm land on 13. That was tricky. All right, what comes out here? In goes 5 plus 5. I know my double facts. 6 plus 5, well, it's only one more, 11. 8 plus 5, well, 8 and 2 is 10, and 3 more makes 13. Takeaway. Oh, but wait, I don't see any of the ends. That means every time to figure out what goes in, I have to do the opposite function. 5 plus 2 is 7, because 7 take away 2 gets me to the solution, 5. 9, I'm going to do the same thing. If I do plus 2, thinking that in my head, 11 went in. Over here, I have to do plus 2 for 3 to know that 5 went in. How great. Okay, now that you know that, I can go on to our math boxes page today. This is a sample. I do, then you do. I'm going to help you see how I did this page, and later you get a chance to do it. You're either going to get a copy that your family will print off for you, or you might be doing it through Seesaw. Or you can do it both ways for fun. So, number 1, Leah colors half a page green. She colors a fourth of the page yellow. Is it more green or more yellow? Here's my suggestion. Actually do this. Take a piece of paper, fold it in half, and fold it in half the other way so that you can make quarters. And I'll show you what I mean. Quarters are 1, 2, 3, 4 pieces. A fourth means the same as a quarter, kind of like 4 quarters in a dollar. So if she colors half the page green, so here I am coloring half the page green, and then she colors 1, 2, 3, 4, a fourth of the page yellow. So it's only one of these 4 pieces yellow. Aha! I'm starting to see which is more. A half is more than a fourth. Which is more, green or more yellow? And I can see more green. You're going to be doing something similar to that. I would suggest folding a piece of paper and doing it the same way. There's more green than yellow. Write the rule. Whew. I'm so glad Ms. DeBoer taught us those in-out boxes, those function machines. So here's what's up. 2 went in, 9 came out. 7 went in, 14, 0, 7. That's super easy, 9 and 16. I know my double facts. I also know the rules, the 0 rule. So I know that it must be plus 7. Here's this. At lunch, 5 children ate apples, 14 children ate oranges, and 7 children ate peaches. Complete the tally chart. First word, apples. Oh yeah, I can go back and check. Remember how to make tally markers? 1, 2, 3, 4, number 5. We'll close the door. Okay, 14 oranges. Is that what's next? Yeah, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And how many kids ate peaches? Oh, here it is, 7. 1, 2, 3, 4, 5, 6, 7. This is interesting. Books read in a week. So I'm going to take a look at this graph. I can see a bar graph over here where this scale side tells me the number of books read from 0 to 6. And then Jerry, Sam, and Ben are the readers. Circle the question that can be answered with this graph. What book did Sam read? Can I tell from this graph? I have no idea. Did he read, an Elephant and Piggy book? Did he read a Dogman book? I have no idea. Can I answer that question with this graph? No. How many books did Jerry and Ben read in all? Do I know how many books Jerry read? He read 6. Do I know how many books Ben read? Yeah, he read 4. So I know I can answer this question. If you want, you can even answer it. Do you know what 6 and 4 is? You got it. Okay. Finally, right here, is this shape a polygon? Explain. Polygons have these rules. Straight sides. 3 or more sides, and it's closed. All right, this is closed. Nobody can get out if someone was inside of here. Does it have 3 or more sides? 1, 2, 3. But does it have straight sides? No. So is this shape a polygon? No. Because it does not have straight sides. So here's your work today. You will see a math boxes page that looks a lot like this, only different. You're going to have a page you need to fold and color. You're going to have a in-out function machine to solve. You're going to fill out a tally chart. You're going to take a look at this graph and figure out a question that could be answered. And finally, you're going to talk about, is this shape a polygon? And then explain your thinking. Does it have straight sides? Does it have 3 or more sides? Is it closed? Could anybody get out if they were inside of there? Thanks, everybody. Good luck on page 178.